All right, guys, we're going to put everything together now. So we're going to do some trig practice with applications. So first couple examples we've done already. It says, without using a calculator, find theta in both radians and degrees. Where, I think this is supposed to be for there. Oops, but I can't move it. Oh, maybe I can. But anyway, just between these two domains, 0 to 360 and then 0 to 2 pi. All right, so go ahead, put me on pause. You can do this. If you don't do it now on your own, you're never going to learn. All right, so let's check our answers here. So don't forget, we might have multiple solutions just based on, being between 0 and 360 degrees and 0 and 2 pi. You guys can check your answers here. Cosecant of theta equals negative square root of 2. Theta could be 225 degrees or 5 pi over 4, as well as 315 degrees and 7 pi over 4. If you're not sure where I'm coming up with this, I would look back in the section of our notes where we originally did this. Maybe rewatch the video to help you there. You guys can check your answers to the remaining ones as well. We're going to move on to our next examples. All right, very similar. Using a calculator now, I'd like you to find, if I can do this again, find theta in both radians and degrees and round your answers to 4 decimal places. Okay, don't forget now, these were the ones where, when you use your calculator, such as, for inverse tangent of 1.2, you might get one answer, but it's possible that you might have another answer as well. So go ahead, put me on pause. Let's see what you got. All right, so as I wrote here, knowing that we have tangent of theta equaling a positive value, we know that this could either lie in quadrant 1 or quadrant 3. All right, so, when we get our answer using our calculator, this is what we get here, which would be in quadrant one. So to find the angle in quadrant 3, we got to figure out, well, what's the angle in quadrant 3 that has the same reference angle? So we add pi and 180, and we get our second answer here. All right, let's see if you guys can do the same thing with this example. Go ahead. All right, so when we go to our calculator, we notice that we get 2 negative answers, which, looking at our domain here, that's not going to work. So added 2 pi and added 360 to get our first answer here in both radians and degrees. So I know I'm going to have an answer in both the third quadrant and the fourth quadrant. So to get my other answer here, I got 3.9897 radians and 228.5904 degrees. Example, we're breezing through this. All right, so the normal daily high temperature T in degrees Fahrenheit in Savannah, Georgia can be approximated by the following. Notice that this is in radians, where T is the time in months with T equals 1 corresponding to January. Find the normal daily high temperature for February, June, and October. This is to help you out. What would T equal, T in the equation, if it were February? 2. All right, so let's have you guys try this. Put me on pause. So this is just really understanding notation here. So for February, like we said, we're going to plug in 2 for T. Make sure that your calculator is in radian mode for all of these calculations. And then also just keep in mind that in our 3 answers here, these are in degrees Fahrenheit, not degrees like angles. Okay, because that might be a little bit confusing. All right, next one. This looks familiar. Similar type of question we've done already. It says find secant of theta, given that cotangent of theta equals -7 and sine of theta is greater than 0. All right, go ahead and try this on your own. My hint here is draw a picture. All right, so I started by figuring that, if sine of theta is greater than 0, it's got to be in quadrant 1 or quadrant 2. And then knowing that I had cotangent of theta equals -7, okay, then it's quadrant 2. Drew my picture, found the value of the hypotenuse, and got that the secant of theta is -5√2 over 7. All right, next example. In traveling across flat land, you notice a mountain directly in front of you. Its angle of elevation to the peak is 3.5 degrees. After you drive 13 miles close to the mountain, the angle of elevation is 9 degrees. Approximate the height of the mountain. So just to make sure that we're all on the same page in terms of what this looks like, let's draw the picture together and then I'll let you solve it. So here's my angle of elevation. This is like the big mountain. I guess I could have made that straight. Mountain. Now that looks like pizza. Okay. So it told us this was 3.5 degrees. And as we drove 13 miles, it looked like it was 9 degrees, the angle of elevation. Remember, that's a horizontal looking up. And we're going to make this the height. Okay. So there's a couple ways we can solve this. I'm going to choose the harder way, just because we haven't really reviewed one of the ways. I'm being very general right now, I know. So whatever way you can think of to solve for this, go ahead and try that. Hint, my way that I'm going to be showing is setting up a system of equations. So that I was going to set up a system of equations here. To do that, I made this x. So I said that the tangent of 3.5 degrees is h over x, and then the tangent of 9 is h over x. Then I solved each of these individually for the variable h. Since both of these equations equal h, I can just set them equal to each other. Then I did a bunch of algebra here to solve for x, which you can either slow me down and like follow my work. Maybe you can try it on your own if you didn't get to it. But then I get that x is 8.178 miles. But I was solving for height, right? So I plugged that into either one of my two equations that equaled height. And I got that the height was 1.295. So make sure, since this was a word problem, I want to have my answer in words, right? So I'm going to answer the question. The mountain is approximately 1.295 miles high. It is important that you have your response in a word format. Next example, it says give the exact value, if possible, of the 6 trig functions given that theta is negative 14 pi over 3. That's what you can do. All right, so I thought it was helpful to figure out, like, what does this look like graphically? All right, so I went negative 14 pi over 3, which I went 1 around, 2 around, and then by my third time here, I landed here, which is at 4 pi over 3. I'm looking at its coterminal angle. So knowing that it was at 4 pi over 3, that was really helpful and easy to figure out my 6 trig. Last example. It says find the reference angle of negative 27 pi over 16. Go ahead, put me on pause. I'm looking for a negative 27 pi over 16. So I wanted to figure out first, where does that fall on, my quadrants? Well, it's found in quadrant 1. So I knew that because it would be between negative 24 pi over 16 and 30 pi over 16, which helped me figure out that my reference angle here would be 5 pi over 16.